Good morning, students. Today's topic is irrational irrational numbers. Irrational numbers. Okay. In the previous two section, we have seen that every rational number can be expressed either in the form of terminating decimal form or in the non-terminating repeating, either in the terminating and non-repeating decimal form, like as 3.45. This is a terminating decimal number, and 0.6666 and dot so on. This is a non-terminating repeating decimal form. We have also seen that every terminating or non-terminating, every terminating and non-terminating decimal expressions can be put in the form of m by n. Okay, where m and n are integers such that n not equal to 0. This topic is clear. Now we discuss about irrational numbers. A number is an a number is an irrational number it has if it it has a non-terminating and non-repeating and non-repeating decimal representation. decimal representation Okay, a number is an irrational number if it has a non-terminating and non-repeating decimal representation. Example: square root 2, square root 5, square root 3, etc. All are irrational numbers. Now we discuss a theorem. The theorem is prove that root n is not a rational number if n is not a perfect square. N is not a perfect square. Prove that square under root n is not a rational number if n is not a perfect square. Here all numbers is not a perfect square, so it is an irrational numbers. Our theorem is prove that under root n is not a rational number if n is not a perfect square. Now prove it. First of all, in that type of questions, let us consider square root n is a rational number let us consider square root n is a rational number, that is, it can be written in the form of p by q, which is in simplest form, which is in simplest form. In that type of question, first of all, let us consider square root n is a rational number, that is, square root n can be written in the form of p upon q, which is in simplest form. Simplest form means that there is no any common factors of p and q other than 1. Okay, now square root n is equal to p by q is now squaring both sides, squaring both side, we get n is equal to p square by q square, that is p square is equal to n q square. It means that n is a factor of p square. It means that n is a factor of p square. Because of p square is equal to n into q square, so n is a factor of p square. This implies n is also a factor of p. N is a factor of p. Okay, now let p is equal to, now in next step let p is equal to nm, n which is n is that number, n m, let n is equal to, let p is equal to n nm, that is p square is equal to n square m square n square m square. Now first of all we take equation 1. Here we take equation 1. Now put the and now from equation 1, now from equation 1 we get n square m square is equal to n q square, because the number is p square is equal to n q square. So we put the value of p square in equation 1, we get n square m square is equal to n q square, that is n q square is equal to n square m square, n and 1 n cancel out, that is q square is equal to n into m square. Here now we observe that we can write n is a n is a factor of q square. This implies that n is also factor of q, okay. Here n is a factor of q. Now we can say that now we can say that n is a factor of p and q both. We can say that n is a factor of both p and q. This contradicts the this contradicts the assumption that p and q have no common factor, no no common have no common factor. This means that our supposition is wrong. Our supposition is wrong. Hence, root n cannot be a rational number. A rational number, that is, root n is an irrational number. Irrational number if n is not a perfect square. If n is not a perfect square. Hence, this question is proved. Okay. Now we discuss one more time. This is very important topic for your chapter. Prove that root n is not a rational number. That is, root n is an irrational number if n is not a perfect square. First of all, let us consider root n is a rational number, and it can be written as root n is equal to p by q, which is in simplest form. Okay, here p and q are integers and q not equal to 0. Now root n is equal to p by q. Now squaring both sides, we get n square is equal to p square by q square. Here n means the square of square under root n is n. So after cross multiplication, we get p square is equal to n q square. This relation says that n is a common factor, is a factor of p square, that is, n is also a factor of p. Okay. Now in equation 1, we put to p is equal to nm. P is equal to nm in equation 1. Here n is that number which is given in your questions. Okay. Next step, we put p is equal to n into m. We get in that equation, we get n p is equal to nm, then p square is equal to n square m square. Then from equation 1, n square m square is equal to n q square, that is, n q square is equal to n square m square. One n is cancelled out. Now we get q square is equal to n m square. Now again this expression, we can say that n is a factor of q square, so n is also a factor of q. But now we can say that n is a factor of both p and q. This contradicts the assumptions that p and q have no common factor. Now because of p and q is in its simplest form p by q, and but here we observe that n is a common factor of both p and q. This contradicts that assumptions that p and q have no common factor. This means that our supposition is wrong. Our supposition is wrong. Hence we can say that square root n cannot be a rational number, that is root n is an irrational number if n is not a perfect square. Hence proved. This is our theorem, and in that theorem there are so many questions in your exercise. Okay, now take some examples.